Hot as hell down there. The air is coming in nicely from both sides. It's burning really nice. That log that was not burnt before is starting to get charred up a bit. We have longer than what we want wood in there. It's just poplar wood we've got in there. We should shut that. Okay, we're going to open up the bottom of the reaction chamber. Don't get too close. And you can see what's happening. There's an intense amount of heat going on down there. We're probably over 2,000 degrees. We just opened up the door of the reaction chamber. That's our target area down there where we all of our smoke has to come down through the bottom. What you're seeing is the gases, the smoke being burnt at a very high temperature. We have a good thick layer of refractor brick across the bottom. We have a nice target area where the gases are injected and air is introduced. A good easy ash clean out. Ash will be very easy to clean out of this stove. It's water cooled on both sides, so we're picking up that tremendous amount of heat down there. Some of the stoves are not water cooled on the sides. They're going to waste, they're not going to get that heat. So everything, all the smoke is pushed out of the firebox, down into the bottom, ignited here, and then it goes up through them 2-3-inch tubes at the back for the first pass of the heat exchanger. Then it does a 180-degree turn and comes all the way to the front. Again, it turns around and goes all the way to the back. You see there'll be no smoke once I shut this up. Again, no smoke. The handle is laser cut in. There's no weld on the outside. Everything is laser precision cut. These two brackets, for instance, were countersunk in and welded from the opposite side before they put the pyramid style gasket trough on. Plastic cover on the handle for safety. We'll open up the refractory gasification area here now and see what's happening down there. With that fire that's happening up there, we're sending all the smoke and gases down into the bottom of the stove where we're igniting them gases. And we're burning them off at a high temperature, as high as 2,000 degrees Fahrenheit. You see how nice and dry it is down there. We're burning poplar wood. We're gasifying very well. It's been cycling on and off. We're taking off a fair amount of heat here on a continuous basis. It's been cycling on and off. The longest it's been off, I think, this afternoon was maybe there. It just shut down just now. The normal refilling sequence would be we would take and we would open this up to allow the gases to escape straight up the stack through the only one pass before we open the door. Then we would open the door to catch the first latch and then open it. And now you can see the fire is actually burning quite well there. But we're going to get her showing the gasification coming down here right away now. Okay, shut that again. Not bad for smoke, really, is it? Nope. Is that gasification or what? Like there's no smoke coming up the stack whatsoever. There's a huge refractory brick bottom in the bottom of this stove with a target nozzle that allows us to target our flame, our gases through the bottom of the stove. We introduce air there. We have water-cooled sides. There's water on both sides of this stove to catch that tremendous amount of heat down there. There's a lot of refractory brick. I'd probably say that we have as much or more of any of the stoves that are made of this type to date. There's lots more. This stove has a multi-pass heat exchanger. The smoke has to travel through two tubes up to the top of the stove, through the water-cooled jacket. It doesn't end there though. We have another 10 tubes going horizontal towards the front of the stove with a 180-degree turn at the front of the stove, returning to the back through another 10 tubes of 1.5 inch diameter. We take as much heat as we possibly can out of the flue gases before they exit the flute. It's a true multi-style, multi-tube, horizontal tube, fire tube boiler style. That didn't come out right. We're looking at the float water level indicator. You can see the water level from a distance. It's very nice and convenient compared to a sight glass or tube. The sight glasses and tubes tend to get discolored or fogged up, and then it gets very hard to see your water level. As I said, as you're walking up to the stove, you can see if the water level's right. Add the boiler treatment. It's Portage and Main boiler treatment. It's made by Certified Chemical. Very good treatment. It actually treats the metal inside the stove and prevents corrosion. If you keep up on the boiler treatment and check for the active ingredient in the boiler treatment, you will prevent corrosion. You will not have corrosion. So we simply, once we get the stove up and going, we pour it into the stove. Boy, I might do this without spilling too. Starting to shower a wee little bit on us here. This is the last thing we have to do to the stove was just started up today. It's our gasifier model. There we go, we've added the certified boiler treatment. You want to do that, check your pH level in your boiler at least once a year, not more often. This is where you could add makeup water too. Very easy to remove, 2-inch cap. You can also put a fill drain line in the house. This is our float water level indicator. You see the float down like that, it's an indication that you need to add water. Ideally we'll keep it probably in the mid-range. I'm setting the Aquaset, I'm turning it up. It's very easy, you just push the button and up and down. That's the set temperature. We're going to turn it up a little bit to get it to come on again. There we go. You can set your differential in here. That's the temperature of the water. That's the temperature we set it at, 190, set point. That's the actual temperature of the water, 183. There we go. This is the operating Aquaset. It turns on and off the blower to make it, as we take the heat off, the blower will come on and build back up the temperature by igniting the wood again. This is the high limit. It is only used if this one fails. If the A419 fails, this one would shut everything down to prevent it from boiling over. We would set it at around 200, 220 degrees, so 212 probably would be adequate to shut it down. 212. They're Johnson controls. They're located inside where they're warm. They're not subject to the weather. They give a lot less problems that way being inside where they're warm. We have dual hookups. The top discharge on each side would be the top discharge, so we have the water coming out the top on the left hand side and also on the right hand side. The return water would return down in the bottom of the stove there. And let's move this out of the way. So we got our two return lines in the bottom, right and left hand side. What happens is the Aquaset actually energizes the solenoid. The solenoid's there to have a positive air shut off so that the fan, no air can bypass through the fan. The solenoid opens and allows air into the unit as the fan comes on. We have a high output fan blowing the proper amount of air injected into along both sides of the stove. It's injected through special designed air ports, and then we also have air coming in down at the bottom of the ignition area of the gases. There's two doors on the back of the stove here, shut nicely. They have nice large paddle locks to open and close. You could lock them if you wanted to. Very easy to open and shut. Let's go at her.